All right. Hi, everybody. My name is Lindsay Seneschal, and for my individual project, I was looking at forest structure change in the Teakettle experimental forest. And specifically, I will be deriving canopy height models from field treatment plots utilizing this LiDAR data. So just moving along, as we all know, California is increasingly vulnerable to forest fires, wildfires, especially in wild urban interfaces, have shown to have the most catastrophic effects for communities. Wildfire risk increases. Insurance companies like State Farm and Allstate have recently just started saying we're not going to cover houses. So we're going to need to find some alternatives to protect the community around us. And field treatments are something that's gaining a lot of gas in the state. A lot of funding has come up for these treatments. So knowing the capabilities of these field treatments and how far they can go and after effects going into the future would be a good thing to study. So in the event of a wildfire, vertical and horizontal continuities can be maintained by these field treatments. However, we don't want to completely stop wildfires because there are benefits to having fires, especially prescribed burns. A lot of vegetation in our area actually is promoted by fires like serotinous cones, and there's a lot of seed regrowth that comes out of these kinds of ecosystems with the benefits of fire. But we just want to look at how we can mitigate that for communities that are at risk. And this is just a photo of a burning house from the 2020 glass fire. So overall, my goal was to use the LiDAR data to study forest structure by creating a canopy height model and comparing the relative height like the 95th mark percentile of these treatment plot heights. And also considering the field treatment effectiveness if there is any at mitigating severe fires, given the results of the differences between all of these things. So the Teakettle experimental forest, this has been an active test research site since the 70s, I believe. And they started a field treatment forest vegetation plot research study in 1997, and ended the treatments around 2001. So those are the plots I'll be looking at. The site is in the Sierras. It's dry climate, mixed conifer vegetation. So you have some Jeffrey pine, red fir, lodgepole pine, etc. This is some of the scenery there. So of the treatments that were done, we have burned and understory thin, burned and overstory thin, burned no thin, unburned with an understory thin, unburned with an overstory thin, and then an unburned no thin plot. So I looked at one of each of the treatments. There were 18 in total, but just for this project being viable in amount of time, I chose just one of each for 6 total sample plots. And I collected neon LiDAR data from all of what they had for the time from 2013 to 2021. So that included data from 2013, 2017, 2018, 2019, 2021. So what I got is I got some of this point cloud data, which before I knew exactly where the plots were, I downloaded pretty much everything within the area of interest, which was about 145 gigabytes. And this is discrete return LiDAR data from the NEON database between those 6 plots. And all these flights were done in June, except for 2021, which was done in July, but all the summer because they have this thing where they only do the flights when there's maximum greenness. So it'll be somewhat consistent in the data. I took the LAZ files, which are pretty much the compiled, compressed files, and then turn them into LAS files to be able to visualize them in GIS. From there, I was able to create a digital elevation model and a digital surface model, DEM and DESM. This is just done by pretty much doing LAS to raster data points. And the point cloud data was already separated into broad classes. So in order to make these DSM and DEMs, you have to filter like the ground versus everything else and then subtract the noise to create those raster data sets. And I created these at a 1 meter spatial resolution. So this is just some imagery showing the DEM models. And then here, just put some hill shading to really show the surface change so you can see the differences between all the trees and the heights and as well as the elevations of each area. And the rainbow colors are the little highlighted plots. So this is from Neon's data set. So to create a canopy height model, you do the digital surface model and then you subtract the digital elevation model from that, and that'll get you the canopy height model. So you can't see that at the bottom. It's the theme I chose. Moving forward after that, after we got the canopy height model, just clipped it to each plot so I could do a zonal statistics on each plot to get pretty much how much of a pixel count was in each height model. So these were my compiled results. Honestly, I didn't see a whole lot of stark differences between just the averages, at least, that I took. I'll go forward a little bit later into the other things I looked at, but yeah. So you can see I got the minimum was all 0. So if it was anything, any vegetation lower than 2 meters was ixnayed and put to 0 because we want to look at the higher vegetation. We have max, mean, standard deviation, and then that RH95. So like the average of where like the 95th percentile of trees were, the height of it. Yeah, so here is the raster cell values based on a canopy height model. We have the count. So this top one would be a burn, and then S is the overstory thinning. So you could see the canopy height's not as tall because you're doing an overstory thinning versus the UN2, which was an unburned and then no thin. So of course you're going to have a little bit more diversity in heights because this is a treatment plot that hasn't been treated. It's more of a control. And then at the bottom here, I just have some maps showing the rasters between, this is 2013, and then the change to 2021. So you can see there's some, like, if you really look hard, there's some like little trees that pop up and have grown in that time. And then there's some that aren't there anymore. Possibly something happened to them. I don't know. Future steps, it would be helpful to look more into delineating the crowns. I read about that. It looked like it really helped kind of outline and border where each tree was. So pretty much differentiating the canopies from each other. I think that would be really helpful to do moving forward. It looked a little too um, something I'm looking into. And then after that, we could also look into DBH measurements. And this is the kind of stuff that is field research. So stuff on the ground, like knowing fuel loadings within the plots would also be helpful to know exactly how adept these treatments are at mitigating fire severity and ignition. Yeah, so I hope you enjoyed I tried to cut it as short as I could. So have a good one and thank you.